All right, let's trace a startup's database journey, from its humble beginnings all the way to becoming a global powerhouse. This is a story of survival and success, and really, it all kicks off with one big question. I mean, think about it. You build something amazing, people absolutely love it, and your traffic just explodes. That's the dream, right? But that dream can turn into an infrastructure nightmare fast. So how do you actually handle that kind of growth without the whole thing just falling apart? Well, the answer isn't some magic bullet solution. It's a journey, it's an evolution, made up of a series of deliberate and, sometimes painful trade-offs. So let's climb this scaling ladder together, one step at a time. Okay, so in the beginning, our startup is just like so many others. They pop their database on a single EC2 instance. It's cheap, it's super flexible, and it gives them total control. Perfect for getting an MVP out the door. But as they get more popular, that total control becomes a total burden. I'm talking engineers up at 3 a.m. doing manual backups, OS patching feels like a high-stakes gamble, and with basically no real monitoring, they only find out something's wrong when it's way too late. The most critical point here, their best people are just fighting fires instead of actually building the product. So they make their first huge trade-off. They move to Amazon RDS. Now, they're giving up some of that fine-grained control, and they accept a slightly higher cost. But what they get in return is massive. Automation for all those painful backups, patching, and monitoring. The operational burden just disappears. It's a game changer for their productivity. And guess what? It works. The product really starts to take off. But of course, this success brings a whole new challenge. This chart just says it all, doesn't it? The primary database's CPU is completely maxed out. All that read-heavy traffic is slowing everything to a crawl, and users are definitely starting to notice the lag. The obvious solution is to offload some of that work. So they add read replicas, basically copies of the main database that can handle all those read queries. Now, the really smart move here was their cost-aware decision. They kept the replicas in the same region to dodge those expensive data transfer fees. It's a cheap and super effective way to scale, but as you might guess, it introduces a brand new kind of trade-off. And then the support team starts getting these weird tickets. A user complains that their friend sees their new profile picture, but they're still seeing the old one. The system is definitely faster, but it's also acting a little strange. So what on earth is going on? The culprit has a name, and it's eventual consistency. You see, because the read replicas are updated asynchronously, there's this tiny delay before they're perfectly in sync with the primary database. For just a moment, they can have slightly stale data. For now, the team decides they can live with it. They just route the most critical reads to the primary and let all the non-critical stuff hit the replicas. But the scaling journey is far from over. Even with the replicas helping out, the database CPU is still working way too hard. So they dig in, and they find a really surprising pattern. The huge majority of their workload is the exact same queries being run again and again and again. Their database is just doing the same work over and over. The next logical step? Caching, using something like Amazon Elasticache. By storing the results of those super common queries in really fast memory, they slash the load on the database. Not only do responses get way faster, but as a cool bonus, they can often shrink their database instances, which helps pay for the cache itself. So the company continues to grow, and with that growth, you get new teams and new challenges. An analytics team comes on board, and they start running these heavy, complex queries for reports. The problem is, these queries are totally different every time, so they can't be cached, and they just start hammering the read replicas, putting the whole system under serious pressure all over again. The team's solution is to scale horizontally. They just add more read replicas, specifically for that analytics workload. And for a while, everything is great. The system is this beautiful, well-oiled machine, a perfect balance of performance, reliability, and cost. Until one day, it wasn't. The entire application just goes dark. Total failure. All of that careful balancing, all of that hard work, gone in an instant. So what was the root cause? A single point of failure. Their entire database setup, the primary and all its replicas, was running in a single AWS availability zone. When that AZ had a problem, it took their whole application down with it. A classic and absolutely devastating architectural flaw. This disaster forces the next big trade-off, an investment in true reliability. They enable a multi-AZ configuration. What this does is create a standby replica in a totally different availability zone, and it's kept in sync synchronously. So if the primary ever fails, RDS just automatically flips over to the standby. It definitely costs more, you're basically paying for an instance to just sit there, but it prevents a catastrophic business failure. And with that move, they enter this long, wonderful period of stable growth. Their architecture is now this awesome combination of everything they've learned. Multi-AZ for high availability, read replicas to handle scale, and a cache for performance. For the first time, they have a system that is truly robust and balanced. But the journey is never really over, is it? The final boss battle of scaling is about to begin. The product is so successful that it's going international. What happens to your beautiful single-region architecture when your users are suddenly in Asia, Europe, and the Americas? And this brings them to the most complex decision they've ever faced. They need low latency for both reads and writes all across the globe. The team is basically weighing two big options. They could use cross-region replicas. They're easier to set up, but you still have that eventual consistency issue and the data transfer costs can get really high. Or they could go for a full-blown multi-master setup, which gives you incredible low latency everywhere, but it is monumentally more complex and a lot more expensive. They make the call. To give their users the best possible global experience, they evolve to a multi-master architecture. And this is a huge leap. It means investing in brand new conflict resolution strategies, way better observability, and a more sophisticated engineering team. The cost and the complexity just skyrocket, but so do their global performance and availability. And here's the real takeaway from all this. They didn't just scale a database. They evolved their entire architecture, one deliberate trade-off at a time. Every single step was a careful balancing act between cost, performance, and reliability, all driven by the real-world pressures of a business that was succeeding. This really brings us to the core lesson for anyone out there building software. Your journey is going to look different, of course, but that pattern of facing and making these trade-offs, that's universal. So that just leaves one final question for you. What is your architecture's next trade-off?